Here's the guide for factoring polynomials. We need to start with the common monomial factoring. Then whatever will be the result, we're going to categorize them as to whether the result is a binomial, trinomial, or multinomial, and we have specific processes under specific results. Then we end it. Let's start with this polynomial. Let's factor x squared plus 5x minus 14. This is a quadratic trinomial for there are three terms and there is a decreasing order of the same variable, exponent of the same variable x. So we have x squared, then x, and we have x to the power of 0 that is actually paired with minus 14, and x to the power of 0 is just 1. So in order for us to factor a quadratic trinomial, first let's check whether this is a perfect square. Perfect square trinomial, because if it is, then let's proceed to the process of factoring a perfect square, and if it's not, let's look for another method. The identification as to whether this is a perfect square or not follows these two different conditions. The first condition is that the first and the last term, or the third terms, must be perfect square. Now we know that x squared is a perfect square of x, so this meets the criteria. Okay, now let's have here minus 14. Of course, 14, even without the sign, cannot be a perfect square because it's not, it's not a perfect square of any integer. But if you would like to, you could also express 14 as negative square root of, its root is square root of 14. So that when you take the square of it, you will still get 14 as a perfect square of the square root of 14. However, the sign of 14 is negative. So just by looking at this is no longer a perfect square, even if you're going to treat it like this. Again, you may treat any number, let's say 8. 8 is not a perfect square, but you could say that 8 is a perfect square of square root of 8. So the square of square root of 8 is 8. Yes, 8 is a perfect square. But here, if we're going to try that, yes, we'll get 14, but the sign is negative. So this cannot be. Just by the first condition for a perfect square trinomial is no longer satisfied. Therefore, it would it would just waste our time in checking the second condition. This means that this is no longer a perfect square trinomial, and we cannot use the process of factoring as such. Here, let's try to look at the second method. The second method is also known as the AC way or the AC method. AC means we are going to multiply the A and C coefficients. The A coefficient is the coefficient or the numerical coefficient of the first term, 1. And your C is your constant. It's not just 14, but it's negative 14 because the operation before it becomes its sign. So here we multiply. The result for AC is negative 14. Now, let's look for factors of negative 14. So we'll have 1 and negative 14 as given. We could also try 2 and negative 7. We could also try the reverse of its signs or the opposite signs. We have negative 1 and 14. We could also have negative 2 and then 7. In order for us to factor this using AC way, let's try to look for pairs of factors here that when added will result to our middle coefficient, positive 5. If ever, just if ever, none of these 4 will return to positive 5 when added, then our given polynomial is non-factorable and we stay as it is because it cannot be factored anymore. But here, we can use this because negative 2 plus 7 is negative 5. And negative 2 times 7 will return to your AC. These are the coefficients that you need. Need for what? Here. Because when we factor a quadratic trinomial, we expect a pair of binomials. Okay? And this is how we take their factors. Square root of the first term. So you will have your x and you place here x as well. Then you place these coefficients. So it's minus 2, so it should be minus 2 here. It's positive 7, so you'll have plus 7 here. Now these are the factors of x squared plus 5x minus 14 using the AC way. If you're not convinced with this, you can always try to use the FOIL method and verify whether these two factors will result to the original. But these are actually the correct factors for this. The next factor we're looking for is for our next subscriber. Subscribe now!